Hello 8th graders. In this IXL video we're going to be taking a look at assignment G2, which is called Compare Numbers Written in Scientific Notation. So all of G2, they're going to give you two numbers. They might be in scientific notation, they might be standard form. You need to compare if they're larger, smaller, or equal to each other. And in this case, for our first one, they say which sign makes the statement true. We have 7.32 times 10 to the first, a scientific notation number there, and 73.2 here. Now, in this case, if they're multiplying 7.32 by one copy of 10, we know that 7.32 times a single copy of 10 is going to give us 73.2. This builds off the idea that when we multiply, whenever we multiply, if the decimal point moves right by one place for every power of 10, then we have a quick way to just do these out. I could just take this decimal point here and slide it one place to the right because I was multiplying by one copy of 10, and I would get 73.2. That tells me that these two numbers here are actually equal to each other. They're the same value, just written in two different forms. And the next one gives us two numbers in scientific notation. One of them is 1.80 times 10 to the fourth. The other one is 1.8 times 10 to the fourth. And it's important to know that both of these numbers have the same coefficient. 1.8 is equivalent. Same thing as $1.80 is the same thing as $1.8. And they're both multiplied by the same powers of 10. So in that case, I know right away, I don't have to do any more math. These are truly the same number. It's just one of them put a 0 after the 0.8, which 80 cents is the same thing as 8 tenths. Now for our next one, we have 6,120 here, and we're comparing it to 6.12 times 10 to the third. So I'm going to take the scientific notation one, 6.12 here, and I'm going to multiply that by 3 copies of 10. That just means that the decimal point here is going to slide right by 3 places. It's going to go 1, 2, 3 places to the right. Which means when I do 6.12 and I multiply it by 3 copies of 10, I'm going to get 6,120. The same number as we see on the left. These two are equivalent. I promise you they're not all going to be equivalent. At some point they're going to give us one here that actually shows one number larger or smaller than the other. And here's our first example. We have 6.02 times 10 to the fourth and 6.02 times 10 to the third. And so in this case here, all we really need to do is pay attention to the fact that they have the same coefficient. They're both 6.02, but this one's power of 10 is larger than that one. So if this has more powers of 10 multiplied and the coefficients are the same, then the left side is going to be larger for certain. So we would put this greater than symbol to say that the power 10 to the power of 4 is going to make 6.02 bigger than 10 to the power of 3. Now here, we'll zoom in a little bit to try to make this easier to read these. It says which sign makes the statement true. We see the coefficients are identical. They both have 5.6 as their coefficient, but this one's going to be multiplied by a 10 3 times. And this negative exponent says this is actually a really tiny number. It's going to be divided by 10 twice. The decimal's going to move to the left. Would get 0.0056 or something like that. So for that reason, we're using the greater than symbol, because 10 to the third power is definitely going to make 5.6 a whole lot bigger than dividing by 10 twice. Here's our next one. This has -2 powers of 10, -3 powers of 10. They have the same coefficient, and I know, hey, if a negative exponent means I'm dividing, and division causes dividing by 10s makes the decimal move to the left, the more 10s I divide by, the smaller I'm going to be. So this first number is actually, if I divide by a 10 twice, it's 0.073. Divide by a 10 twice means the decimal slides left twice, 0.703. And I missed a 0 in there, my fault. But I'm going to get 0.0703 there, or about 7 pennies or 700ths. Here, I'm going to take that same coefficient, 7.03, and I'm going to divide by the 10 3 times. The decimal's going to go left one extra place. So in that case, instead I'm going to get 0.00703. Because this decimal had to slide left 3 places. And I know now that this number here, even though they're both small decimals, 7 cents is a lot more than less than a penny, which is what they're showing us. So for that reason, I'm going to pick that greater than symbol, and we'll keep it moving. Alright, now this time we see they have the same powers of 10. They're actually not going to be multiplied by any 10s or divided by any 10s. They're going to be multiplied by 1. That's what the power of 0 makes. So really the powers of 10 don't matter at all here. They're the same and not changing the coefficients. And I know 7 is bigger than 2. So I'm going to go ahead and pick the symbol here that shows me that the right expression is larger than the left expression. Or really it's saying the left expression is smaller than the right expression. At this point, we believe you are definitely in great shape to do the rest of G2 on your own. I'm going to go show a few problems from the challenge zone in case students were getting stuck on the more difficult problems. So not quite the challenge zone, but here we see a little more difficult because they've... Ooh, quite a bit more difficult. This one's 9.3 times 10 to the negative fifth. So I'm going to go ahead and take that number and convert it to standard form to see what it looks like. I have 9.3 times 10 to the negative fifth. When we divide, and that's what a negative exponent means, divide. When we divide by powers of 10, the decimal moves left. So this one, 9.3 times 10 to the negative fifth, really means I'm going to have to take that 9.3 here, and I'm going to have to move the decimal 5 places to the left. So I go to do that, and the first time I move the decimal, I'm going to get to 0.93, and now I have to go 4 more places, so I know after the decimal I'm going to get 4 zeros, and then the 93 showing. If I move left 5 times, the first time is to make it 0.93, and I still have 4 more divided by 10s, and that's going to create 4 placeholder zeros. So I know that this number is now equivalent, let's get that little way, to 0.000093. And this one times 10 to the fourth, we know this decimal point is going to move right 4 places now. So I'm going to go right by 4 places and see where that gets us. 1, 2, 3, 4. And if I zoom in there, we see that there are 1, 2, 3, 4 zeros and then the 93 left. So it turns out, even though these two numbers were difficult, they both make 0.000093. If I move the decimal 5 places left, or I move this one 4 places right, we end up with the same number. So these are going to be equivalent, but definitely a tougher problem. We're going to skip ahead a little bit further even, and these are definitely tough problems as you get deeper into it, but we're going to go into the challenge zone to see which difficulty is there. Thanks for being patient. Alright, and it looks to me like the challenge zone is difficult, but nothing that we couldn't handle. So first off, I'm going to take a look. This one is 10 to the power of 11, and I want to see how many powers of 10 this one would need. So I'm going to go ahead and count how many places the decimal would have to move to get to 1.51. 3 places, 6 places, 9 places, 10, 11. We could call this number here 1.51 times 10 to the power of 11. And to move the decimal 11 places to get it to 1.51. This is 1.15 times 10 to the 11th, so they have the same powers of 10, but $1.51 is more money than $1.15. So if you have more money to start with, and they both get multiplied by the same powers of 10, in this case 11 copies of 10, that 1.51, that $1.51 is still going to be more than the $1.15 after they both get 11 powers of 10 multiplied. So for that reason, we're picking the greater than symbol here. We'll look at one more challenge zone problem. It looks annoying at first, and if I tried to move the decimal 75 places to the left or right, it would be an annoying problem. But here right away I say this same coefficient, this one's being divided by a bunch of 10s with the negative exponent. This one's being multiplied by 10 a lot. The one that gets multiplied by 10 is going to be way bigger than the one that gets divided by 10. So that gets us to the end of our G2 tutorial. Thank you to watching to the end of the video. If you did, this is tough work. Keep up the great stuff. And if you're still a little bit stuck or you need a little bit of help, please feel free always to reach out to me by email or GChat. Again, my email address or my GChat is ddoherty3, and that's at bostonpublicschools.org. Thank you again for watching to the end of the video, and keep up the great work.